Welcome everyone to this week's episode of the Weekly Space Hangout. I am not Fraser Cain, I am Pamela Gay. I'm on the faculty at Southern Illinois University Edwardsville, and this week I am hosting in place of Fraser Cain, who is hopefully off enjoying a fabulous European vacation with his family, and we hope to have him back here next week returning to his position as host. We're going to spend just a few seconds making sure this is shared out across all the different websites. So if you've managed to already join us, we apologize, and you get to watch us type for a moment while I try and talk and type at the same time. If you could also follow along and share us out along with your networks, we'd really appreciate it. We just want to get science news out to as many people as possible, and your help is always welcome. So you can watch us on my feed. I'm, as I said, Pamela Gay. You can watch us on my feed online, or you can tune in on the CosmoQuest website, where you can watch us on, actually I'm not sure how to get the embed code this week, so you may only be able to watch us on Google Plus this week. Do any of you see how to get embed code anymore? So for those of you who don't know, yesterday Google launched a brand new fully featured Google Plus, but it seems that the Hangouts, the Better Hangouts on Air plugin is no longer working, which is how we got the embed codes to put the Hangouts in other websites. And I'm just not seeing how to do that. Nancy, Alan, or are either of you seeing this?
No, I'm not seeing it.
I guess there's the post.
Yeah, that's just not the embed code. Okay, so I'm going to put a note up saying that you can't get there from here.
Oh dear.
Over on the Hangout site. So we apologize for our technical issues. This happens. And now I get to find out how well my code works when I randomly add URLs to things. Okay, let's see if that worked. Okay, so I'm going to retweet a correction. So thank you, Google, for helping us so much in getting this fixed. We know yesterday the folks at Google, with their brand new updates to everything, they, like every other developer out there, released a whole bunch of new things and found things broke. That happens, and they last night were gracious enough to let us know everything was working again. And so we'd just like to give a shout out to all the developers at Google who we hope are now getting to sleep, having gotten everything working. I know that the weeks leading into launches are usually pretty sleepless. And hopefully we'll be able to get all of our embed codes and stuff working again shortly. So we'll hopefully have that fixed quickly. I can't type and tweet though, so one moment please. Okay, so I think I have everything retweeted everywhere. So welcome. Once again, this is the Weekly Space Hangout. If you're out there watching, we'd ask that you please +1 and that you share us out, tweet to us. We will be following Twitter on the hashtags #CQX, #Hangout, and welcome, and we are sorry for the technical confusion on where to watch. But without further ado, I'd like to introduce the folks who are with me now. From left to right on my screen, we have Alan Boyle from MSNBC, Nancy Atkinson from Universe Today, And we will have Emily Lakdawalla at the Planetary Society joining us in just a few moments, we hope. Now, this is an amazingly interesting week in history for space. Today, April 12th, when we're recording, is Yuri's Night. This is the anniversary of when Yuri Gagarin became the first man to go up into space, and also the anniversary of the first launch of the U.S. Space Shuttle. And we're waiting to see if another country joins the space race. And Alan, I'd like to turn to you to discuss the new North Korean possible launch that we're all waiting to see what happens.
Yeah, we're in the launch window for the North Korea's satellite launch. They tried 2 times before, and North Korea insists that they were successful, but everyone thinks that was really a mirage, just to you know, satisfy the great leader's ambitions. And so this time around, they invited press to come in to witness the preparations for launch and hopefully the launch itself. And so our own Jim Oberg, space analyst for MSNBC and NBC News, is over there. He did his own chat from Pyongyang just a couple of hours ago, and has also sent in a fresh story for our website on the subject of what happens if it doesn't work. And so there are lots of things that could go wrong. And Jim, after taking a look at what was going on at the launch site in Tongchang-ri, is thinking that it's more likely than not that this is not going to work, just because there are all sorts of things that could go wrong, and he's worried that there's so much pressure to launch something to commemorate Kim Il-sung's birthday that they'll have the North Korean equivalent of go fever. But we'll see how that happens. A lot of wondering about whether this is really a test for an ICBM, and it does look as if it would be somewhat easy to change this operation over to an ICBM launching operation. This particular missile is not configured in such a way that it could be used as an ICBM. It's going to go on a polar orbit. The North Koreans say it'll be a sun-synchronous orbit. What they want to do, what they've been telling people they want to do anyway, is that they want to use this for overflights of North Korea to keep track of what the terrain looks like. They had some floods a couple of years back that were pretty bad, and so they want to try to have some sort of weather satellite capability. Well, this is what they say, but actually I think it's all about having the status of a space program, and at least North Korea feels confident enough to bring people in, show them around the launch pad, and they're looking for validation from the outside. Jim Oberg has been pressed multiple times to say that this looks like a peaceful program, and he's resisted buying into what is clearly a propaganda campaign to reassure the outside world that North Korea has no warlike aspirations, even though some of their posters show missiles slamming into the U.S. Capitol dome. So it's a very weird world. I'm watching this from MSNBC headquarters in the Seattle area on the Redmond Microsoft campus, and so I can only be an observer of what's going on in Pyongyang and Tongchang-ri, but it is sort of fascinating to see this clash of cultures going on, and we might get a launch out of it. In the next 3 or 4 days, there are going to be launch windows coming daily. I think, Pamela, you were saying that you were kind of glad that the launch didn't take place on the anniversary of Gagarin's flight and Yuri's night, that holiday is still kept its its pure
human space
nature.
flight. Yeah.
Right. So we don't need to muddy the waters with North Korean satellite launch on Yuri's night, but we'll see how it goes over the next couple of days.
It's definitely been an interesting story to watch the progression of, and this is something that has a lot of far-reaching consequences. A lot of commercial airlines have actually changed their flight paths because they're concerned about inadvertently ending up in the path for the rocket. And with all initial rockets, you never know if they're going to stay politely confined to their path or not, so there's concerns there. So that's fuel costs, that's planning deviations, which cost time and money. And it's just been interesting to watch the reporters over there try and figure out how to carry the story. And Jim Oberg was actually doing a really excellent job handling live text questions over on MSNBC earlier, and the entire set of conversations is archived. And it's really worth going through and reading what he did and didn't respond to. There's a lot of telling about how they're probably being watched very closely over there. This is something that is playing out in real time, and it's a sensitive issue, and no one knows quite how it's going to play out yet. So we're going to have to stay tuned as this story continues to progress. But to move to lighter and friendlier things, Nancy, you have a story in Neutrino Communication. So let's go from war to just talking to one another.
Yeah, communicating with neutrinos, it all sounds pretty fanciful, pretty crazy, but a group of scientists were actually able to do it. Scientists at the Fermi National Laboratory were able to send, and they used a pulse of neutrinos, and they were able to send the beam through about 240 meters of solid stone to a receiver on the other side, and they spelled out the word neutrino in their kind of telegraph-like pulses. So, it all sounds kind of rudimentary, except for that part about using a 170-ton particle accelerator and using neutrinos to send a message, of course. But to Alexander Graham Bell's first message using his first telephone. And they were able to send messages for a couple of hours and only had a bit rate error of about 1%, so they thought it was pretty successful. We know that the sun naturally emits probably trillions of neutrinos every second, so, neutrinos sent through rock wasn't all that surprising, but basically figuring out how to send and receive is a pretty important step in figuring out how to use neutrinos for communication. There are times when communicating via radio transmission just isn't going to cut it. For example, we have a very real problem today in that we can't communicate with planetary spacecraft when they're on the other side of Saturn, for example, or Jupiter, or the Moon. So if we ever want to, be able to constantly communicate with planetary spacecraft, that would be helpful. Science fiction-y type thing if we ever want to try any interstellar communications. Of course, radio communications just aren't going to cut it either. And then there's also practical down-to-earth uses for this, like communicating with coal miners or miners down deep in the earth. That's sometimes a problem. There's point-to-point global communication problems and submarine communications, so that might be helpful. So, but given the kind of limited range and the low data rate that they used and kind of the extreme technologies that they used to achieve this, the team wrote in their paper that significant improvements in neutrino beam and detectors are required for practical applications. So this is kind of a first step, hopefully, to eventually be able to use neutrinos for things like deep space communications and that kind of thing. So it's pretty fun.
It's going to be interesting to figure out how they deal with a lot of the personality quirks of these neutrinos, because one of the things that left us baffled for decades with the sun is the neutrinos between here and the sun like to change identities, and they flip back and forth between the different types of neutrinos, which all require a different technique for measuring them. So as we try and figure out how to use this technology, we're going to have to figure out how to effectively detect things that don't like to be detected and that like to change literally their mass and energy ratios. So this will be an interesting challenge to watch the technology evolve over time. Now, a more lighthearted form of technology that probably goes back to the beginning of humanity is the distillation of alcoholic beverages. And astronauts in space are going to want the same things that us folks down here on Earth want. So we have a story involving whiskey in space from you, Alan, so I turn it to you.
Yeah, this is really kind of a fun thing. We're really going from North Korea gloom and doom to scotch in space. And what this is all about is really trying to figure out what the chemistry of making beverages is and how it's affected by the zero-G environment. And so what this distillery in Scotland, Ardbeg, did was that they arranged with NanoRacks, which is a company that arranges to fly experiments into space, to put some unmatured malt and some charred oak particles into space and let those simmer for a couple of years and then see what happens. And so it sounds like we're going to have tipplers in space, that all of a sudden we're going to have a distillery up on the International Space Station. But that's not really the case, that the astronauts aren't going to do anything with these samples. And the samples are so small, the total amount of liquid is something around 1/8 of a shot. What they're going to do is bring these samples back down after they've matured for a couple of years and then put them through laboratory tests. They're looking at a particular type of chemical called terpenes, which play a big role in the aroma and flavor of a whole lot of things, including scotch. And so they'd like to see how zero-G affects the chemistry that is involved as these terpenes interact with the charcoal and the other ingredients in the malt during the maturing process. This might be applied to new techniques for distilling and maturing scotch on Earth. Farther on down the line, yeah, maybe there will be scotch in space. If someone finds that there is a new interesting taste that comes about because something is matured in zero-G, who knows? Maybe they'll have kegs of this malt going up on, say, a SpaceX capsule, going into orbit for a couple of years, coming back down, and then this is going to be the latest rage for millionaires to try some of the zero-gravity scotch. People have also tried various other things with alcoholic beverages. For example, the Sapporo Brewing Company had some seeds that sat around in space for a few months, and then grew barley from those seeds, and then turned the barley into beer, and then sold what they called space beer. And that was really pretty much a publicity gimmick. Another company from Australia has been working on a type of beer that could be drunk in zero-G. If you think about it, the carbonation in alcoholic beverages might be problematic for someone traveling in space. And so if you're a space tourist and you're sitting on your Virgin Galactic space plane and you've paid $200,000 for a seat and you're thinking, well, you might want a little champagne or a little beer to celebrate, it's going to be complicated to do that in zero-G. It could turn into a real mess. There's also a problem if you drink this stuff and it's carbonated in zero-G, you might have some of it coming back up on you. So what they're trying to do is develop low carbonation beverages that you could drink in weightlessness, and it's not going to cause problems for the decor or for your biology. So it's a brave new world. It's a new frontier for the final frontier, and in a couple of years, hopefully we'll hear how the distillery managed with this experiment, and who knows, maybe there'll be a little bit of trickle of scotch for somebody to try. I'd love to try it, but I have a feeling that I'm not going to be in line for that taste test.
Well, what's kind of awesome is throughout all the history of modern transportation and alcohol production, there have always been people trying to find new ways to get that perfect flavor. And I know that there's different forms of alcohol that, for instance, they put on ships to cross the equator because the motion on the boats does special things to the fermentation process. And who knows how yeast will respond to zero gravity. Maybe this will be the great new way to create new artisan alcohols for the wealthy here on Earth. But we do need to be careful consuming in space because there are all new forms of jet propulsion involved. just taking the cork off the bottle is dangerous enough, and I think I will leave the rest to your imaginations. So we seem to be running into problems getting Emily in here. So if any of you out there have any questions, we'll be taking those in just a moment. We have one more coming attraction story that I'm going to turn to Nancy with, and I know you just want to give us a preview of something that's going to be coming out on Universe Today later today.
Yeah, and I know other sites have been running this too, but it's just too juicy not to write an article about it. A scientist writing a paper, and it's actually a chemistry paper about the building blocks of amino acids. And kind of one of the conclusions that the researcher came to was that perhaps that on other planets there could be advanced dinosaurs ruling the planet. So it's just like I said, something too juicy not to miss. His concluding statement was that we'd probably be better off not meeting the beings from this other planet if it does exist. So. Pretty cool.
It's the old idea that what evolved here could easily have evolved elsewhere out in the universe, and if the dinosaurs hadn't gotten thwonked with an asteroid that changed the entire environment, who knows, maybe they would have actually become intelligent at some point, or the velociraptors would have truly ruled the world Jurassic Park style.
Right.
It's kind of awesome to imagine.
Right, exactly.
Now, we have a question coming in from Daniel Behringer who asks, does this distillation idea have long-term applications for making food or useful chemicals in deep space colonization missions? Were there any other applications discussed, Alan?
Yeah. In fact, there are a lot of studies that have been done and efforts that have been made to look at how aromas and flavors are changed or affected by zero-G. A few years ago, people sent a rose up on the shuttle and then tried to see if there was some sort of new fragrance that they could develop, because it appears that the fragrance of the rose was more intense in zero-G, and so they're kind of looking into why that is. Another well-known effect is that your taste is a little bit more subdued in zero-G, and they think that's because of a number of factors, including the fact that you kind of get stuffed up, that you have fluids that are retained by your head. It's like you have a cold during the first few days of space, and so that reduces your ability to have that smell and taste that goes along with eating food. And so a lot of the astronauts like to shake on the hot sauce when they're preparing their meals. And so there's going to be a lot of research being done, and that will be done, into the effect of the space environment on taste and smell. And as you said, Pamela, if there's a new trick, if there's a new chemical trick that takes place in zero-G, they'll try to replicate that on Earth and make a gimmick out of it. You can bet on that. The Jeff Mamber, who is the managing director of NanoRacks, told me that in the wake of all these stories about Scotch whiskey in space, he's gotten a lot of inquiries from other companies that want to do consumer product research in space now. And it's getting to the point that if you have a little experiment, you can fly that up for less than $100,000. And that's starting to get into the realm where somebody can take a chance, maybe make a little bit of publicity out of it, and maybe actually get a new twist for a product that they would be able to use on Earth and perhaps eventually in space as well. Of course, in the longer term, you're going to have a lot of applications that are going to need to be developed in order to make life in space on a settlement, whether it's in orbit or on the moon, more pleasant. And that's going to involve development of new foods, hydroponics, new ways of raising crops for for space consumption, and ways to enhance the flavors in space. And so I think that this is kind of one small step toward a giant leap in space food preparation.
And the reality is, human biology evolved here on Earth with gravity, and most of the chemistry that we do, it's actually just slightly different in space due to changes in how things mix, how they settle out. And one of the original justifications for the International Space Station, for many of the different ways that we developed to run experiments on the U.S. Space Shuttle, the justifications were that we'll be able to do chemistry and biochemistry experiments in space, perhaps developing pure drugs. One of the neat things is crystals form much purer, much easier in some chemical reactions in space, because you don't have to worry about things growing all over the sides of your container when you can grow them in a bubble and things like that. So there's all of these different things that have been worked on for now 30 years of research, and with the International Space Station finally completely constructed for the most part, they're settling in to start doing the science. And the prices are coming down, and what's going to be interesting to see is how the suborbital market changes everything. Some of the racks that they're looking at to put on the suborbital spacecraft, they're saying that you'll be able to launch a shoebox-sized experiment for admittedly only a few minutes of zero gravity, but a shoebox-sized experiment for as little as $1,000 launch cost. So now you're starting to get to the point that even small businesses can do spaceborne gimmicks, and it starts to become interesting.
Right.
And
that's right. I was just going to say that Alan Stern, who is a champion of suborbital research, has called this a potential killer app for suborbital spaceflight, and a way to jumpstart it. So it's not just all about millionaire space tourists. It's about people who are actually doing research. Maybe it's a few minutes, but everyone wants to get to that phase where you can do orbital research. And so everything in space nowadays seems to involve SpaceX one way or the other, and so SpaceX has their Dragon Lab as a potential platform for space experiments, and Jeff was joking that one of these days you might see a SpaceX Dragon Lab launched just filled to the brim with kegs of whiskey to mature. But why not? If it makes space profitable, that's what it's all about.
They've already launched the cheese. I'm waiting for the wine. That's what I'm waiting for. No, we have a few more questions out in the feed. I'm going to try and blow through a couple of these kind of quickly. So Yuan Shen asks, do you know how many viewers are watching and their identities? No, I'm afraid we, like you out there watching, have no clue how many of you are out there. And this is where we ask everyone, can you please +1? Now, admittedly, when you +1, we now know who you are, but we won't do anything evil, we promise. We just want to get a sense of what's our audience out there, and we will be posting this up on YouTube, and we know that more people will watch it there, and then we can see the numbers of views, but we don't get identities off of that. So the next question I have comes from Stefan De Decker, who asks, any recent developments with regards to NASA's budget cuts to planetary science? Do either of you want to address that? I don't know of any new information. Do you know of anything?
Well, only that there have been all sorts of congressional hearings. Congress is very concerned about the cutbacks in space science research, and of course it's starting to get to be a little bit of a political thing where during congressional hearings people are wondering why so much money was set aside for commercial spaceflight, for example, and why isn't there more money for developing the super duper space launch system rocket, and what about these cuts to planetary science? And so I think as these bills work their way through Congress, you're going to see a lot of shifts, and I think there's a lot more potential for planetary science to get more funds as it goes through the congressional process. But it's like watching sausage being made, as Bismarck once said. It's something that sometimes it's not fascinating to watch this process during some phases of the process, and I think that we're in that part of the process right now.
And one thing that I think a lot of people don't understand is that the funding that's going to the commercial space agencies is actually helping to fund a parallel set of rocket development. So when we look out at SpaceX, when we look out at Blue Origins, who are recipients of some of this commercial space agency funding, they're working to develop necessary things that NASA isn't spending money on. And if NASA were trying to build the space plane that Blue Origins is working towards, if NASA was working to develop all of the different things that Elon Musk's team at SpaceX is working on, they'd be spending a whole lot more money than what they're seeding these commercial space agencies with. So this actually represents an overall savings to NASA to seed money to these commercial space agencies. So that's something that we as communicators definitely need to work to try and get across. It's now looking at a future with we're going to have, just like there's multiple places to go buy an airplane, there's going to be multiple places to go buy your mechanism to launch your scientific experiment built with NASA dollars into space on a vehicle by NASA or Blue Origins or SpaceX. It all gets to the same place in the end, and that's up, hopefully. So another question that we have is from Ian Denniston, and his question is, would it be possible to use natural neutrinos for communications, or are we looking at needing ways to generate them efficiently? Nancy, do you want to take a stab at that?
Sure, and I think this points to what you mentioned earlier, Pamela, is that the natural neutrinos have a tendency to kind of change their characteristics, and we don't really understand that. And so I think maybe the key to this would be able to create synthetic ones that we know that they're not going to change, that we can predict what they're going to do and predict where they're going to go. So yeah, I don't really know if natural ones could be used, or if like I said, the key to this is developing synthetic ones that that might do what we really want them to do.
And the real issue here, looking at the physics of it, is a neutrino is a neutrino. So if it starts at the sun, it's going to change its identity 2/3 of the time before it gets to Earth. If we create a neutrino here on Earth, it's going to, if it travels the distance to the sun, change its identity 2/3 of the time. But if we create it here on Earth, we know where it started and when it started. If we're catching neutrinos traveling through space and trying to figure out how to steer them, we don't know how to do that. And so it's simply a matter of if we try and catch these things that don't like to interact and steer them, we can't. And the way to think of it is generating them artificially is no different than generating radio waves, which are artificially generated photons, and using those to produce a radio station. So all of those big radio towers that you see while you're driving around, those are artificial photon emitters, and the Large Hadron Collider is an artificial neutrino generator in some cases. Same idea, both being used for communications now. One of them we've figured out much better, and we can detect with your car radio. So give us time. Maybe we'll get the neutrino detection better figured out, but the particles really don't like to play well with others. So joining us, for those of you watching, is the wonderful Emily Lakdawala, who has just saved herself from a meeting, and we're really glad that you were able to join us, and you are bringing us interplanetary information from the Rosetta craft, I believe.
That's right. The Rosetta mission is a mission to a comet that is actually asleep right now because it's a solar-powered spacecraft. The Europeans can't build nuclear-powered spacecraft. It's solar-powered, and in order to get to its comet, it has to go way out to the orbit of Jupiter, and unlike Juno, it doesn't have solar cells big enough to power it at that distance from the sun, so it's in hibernation for several years, and we really, really hope that it's going to wake up when we expect it to, when it's time for it to encounter the comet in a few years. But on its way to the comet, it passed by a couple of asteroids. One was called Steinitz, and the other was called Lutetia, if I pronounce it the way that the Germans do. Lutetia at the time was the largest asteroid ever visited by a spacecraft, although it was very quickly overshadowed by Vesta. But historically, the German builders of cameras on planetary spacecraft have been rather tight-fisted with data. It's been a problem on several missions, but there was recently a leadership change on the Rosetta mission, and as a result, data has been flooding out from them. So last year, just a few months ago, actually, they released all the data through the Steinitz flyby, which also includes flybys of Mars and a couple of Earth, with some really dramatic photos. And then just a couple weeks ago, they released the data from the Lutetia flyby, and it's absolutely stunning. I've got 2 photos queued up that I'm going to screen share with you and kind of show you around them. So these are photos that were put together by a Czech amateur image processor named Daniel Matusek, who I'm sure his name I'm murdering, but that's how I say it. And this is the globe of Lutetia. Lutetia is a fairly large asteroid, like I said. It's about 132 kilometers across on its largest dimension. That makes it similar. I'm looking up because I'm looking at a big poster I have, a cheat sheet above my monitor. It's about the same size as Saturn's moon Epimetheus. So it's a lumpy thing. It's relatively small. It's too small to be round. But it's large enough to have some of the same kinds of complicated geology that Vesta has. So you can look and see at some of its craters where, just like they're talking about on Vesta, this one especially up here, you see how it has one very sharp edge and one very smooth, kind of degraded looking edge. And that, we're learning on Vesta, is the hallmark of an impact onto a very steep slope, where as the asteroid comes down and hits here, it makes the shape of crater that you'd expect to see, but it's so steep on the uphill side that a landslide follows the formation of the crater, and it actually runs out over the downslope crater wall. And so I see, now that I've seen Vesta, I see a lot of very similar looking craters on Lutetia. One of the things that's different about this asteroid, though, is that there's almost no color differences anywhere that you can see on it. You have to really stretch the heck out of these images to see any color differences across the asteroid. The one that's really obvious is this sort of dark area around this particular crater that's right on the terminator. But these photos, they're absolutely gorgeous. I encourage you to go to my blog and look at the video that Ian Regan put together from all of the flyby images. I don't think I'll try to play it here. I'll just ask you to go look at the video. And it's just, one of the commenters on the video, this was funny, he said to take an iPhone or a smartphone, use it to look at the video, turn off the lights in your room, and pretend that you're steering the spacecraft as you're flying past it. And at the end of it, you get to a view that looks like this. And this is the departing shot of Lutetia from Rosetta. And what a strange looking world that is. And it's one of the biggest asteroids out there. I don't know exactly what its rank is, but it's pretty big. There's probably not approximately 1,000 things of this dimension, maybe only a few hundred. And it's just one of many out there in the asteroid belt to be explored.
That's really, really beautiful.
It's quite a dramatic landscape.
Yeah, and it's going to be amazing to see what we learn about our solar system as we continue to send all these spacecraft out and look at all these different objects. And we're learning that the potatoes have very diverse and complex geography attached to them. And
yeah, and it's interesting how after visiting another potato, when I go back and look at this potato, I see things that I didn't see before I saw Vesta. So every time we see a new one of these things, it basically multiplies. It's like an added exponent on what we learn about all the other asteroids. It's very powerful in that way. And of course, Pamela, you've given me a great opening to say that now, especially outer planets and Mars exploration, but outer planets, the asteroids are often lumped in with the outer planets because they're also very far away and rather hard to get to. And most of the visits that we've done to asteroids, or many of them, have been flybys by spacecraft that were on their way to other places. And you know, we don't actually have another Outer Planets mission planned after Cassini ends its mission in 2017. There is nothing. There is absolutely nothing even in development. Juno's out there. Juno's mission will actually end before Cassini's does, and that's it. There is nothing coming, and there won't be anything coming unless we advocate for more funds to go to NASA's planetary division to finally start some of these missions that we've been talking about to Europa and Enceladus and Titan and some of these other great places across the solar system, and cheap small missions too to near-Earth asteroids, which are also of great interest to those of us who want to protect Earth from being hit by one.
So right now we're in a situation where New Horizons is really the last shot that we've got for the truly outer parts of our unexplored solar system edges.
Yeah, but New Horizons will get amazing photos of Pluto and Charon, and hopefully of Nix and Hydra as well, although those will be lower resolution. The photo that it will get of whatever it passes by, no matter how close to the trajectory, we do find an object using, what's the new?
Ice Investigators.
Ice Investigators. No matter, and all of you need to go to Ice Investigators and find us a target for...
That's at cosmoquest.org. It's linked off the homepage.
It's up to you guys to find where New Horizons is going to go to next, but no matter what we find, the pictures are not going to look this great because we're not going to get that close to it. So as far as getting spectacular images from the outer solar system are concerned, Cassini is it and actually New Horizons will fly past Pluto before Cassini ends its mission. So that's where we're at. Juno and New Horizons will get some pretty pics. Cassini will die, and then there's nothing after that.
Yeah, and this actually transitions nicely to a question that we have from Josh Andrews, who asks, of the 3 ESA missions that are up for launch in early 2020s, JUICE, Athena, and NGO, which of these would you like to have selected? Now, I personally tend to just stay out of the argument and stand back, and missions are dead to me until they've actually launched and reached orbit. So I don't know if any of you have any opinions on
Yeah,
these.
Pamela, I'm actually with you. I do not pay any attention whatsoever to missions until something has been shipped to a launch site. Then I start paying attention. It just doesn't pay, because they wind up being, there's so many changes. I mean, just look at ExoMars, look at Luna Globe, or any of these upcoming missions. They'll be great when they get launched, but really you got to be cutting metal before you can be expecting to see something launch, and even then it can be constant effort is needed to make it get to launch.
It's so easy to get your heart broken. I had a X-ray satellite that I needed for my dissertation blow up on launch, and I know Fraser and I both had our hearts set on terrestrial planet finder. It never got anything. So, yeah, it's easier to simply be oblivious until they're there and ready to go.
Nancy, do you pay attention to these mission proposals more than we do?
Not too often. A lot of times we'll cover, new concepts, new ideas, just as kind of a, people are interested in kind of the latest concepts that are being developed. But yeah, again, you can't get too attached or too excited about a mission until it's, it's at least past a design review, that kind of thing.
There's always been a discussion about, well, where, you mentioned Europa and Enceladus, Europa at Jupiter and Enceladus at Saturn, and I think Carolyn Porco, who is in charge of the imagers for the Cassini mission, made a very strong case for going to Enceladus. That's the Saturnian moon that has these geysers coming out from it, and she thinks it's one of the most interesting places you could go to. I guess JUICE is targeting Jupiter and the Galilean moons, including Europa, and so I would, if I had to choose, I would have a soft spot for that mission for sure. But again, they're all pretty valid, and it's a long way before they make that selection. So I guess I'll go with you, Emily, and kind of hold off until the dust settles.
But I think that you mentioned that Carolyn's a very vocal, of course, proponent of a mission to go back to Enceladus or possibly Titan as well, I think. And there's a lot of effort being directed right now at scientific organizations. Leadership of both the planetary division of AGU and of the Division of Planetary Sciences of the American Astronomical Society are now pushing their members to advocate at Congress, which is really great. Congress does need to hear from the scientists doing the work, but they all tend to have a favorite horse in the race, and it's also important for them to hear from people who just generally want us to get out there again. Personally, I don't care about the choice between Europa and Titan and Enceladus as much as I care about getting a mission off the launch pad and out there again. I might have personal favorites, but I'm not going to express them. I want to make sure that we're in the game, that we're getting spacecraft ready to continue our tradition of exploration.
And this actually, I'm going to destroy this person's name. I apologize. It's a Greek name written in Greek. So I believe the first name is Athanadios. I'm sorry. I know I destroyed that. And he's asking, what's the cost for launching a probe to one of Jupiter's moons, roughly? Are there estimates on that?
Roughly $1 to $4 billion. It all depends on what the envelope is. So there's actually a long history with the Europa mission where in the planetary decadal survey, which is where NASA asks a panel of experts to come up with recommendations for what NASA should be doing over the next 10 years. The decadal survey that happened 2 years ago said, okay, you outer planets people, tell us what you would do if you had an unlimited funds. And they were like, do you really want us to do that? Are you quite serious? And they're like, yes, that's the only mission you're allowed to tell us about. So they proposed a mission that was $3.8 billion and had 2 spacecraft and did all kinds of great stuff. And then this year's decadal survey, they said, well, you know, a mission to Europa would be nice, but it's way too expensive. It would cost $3.8 billion. And the planetary said, no, wait, we can do a mission for it's still very expensive, but a much less expensive 1.4 maybe, something like that. It's still a flagship mission, but it's not going to break the bank, provided that your bank does contain that much money. So it all depends on what your goals are. You know, if you want to orbit, if you can stay in orbit around Jupiter and don't have to get into orbit around one of the moons, that saves a lot of money. It also being able to be more distant from moons is actually kind of a trade-off because you have to have bigger instruments that can see at higher resolution in order to get down all the way to the moon, but you're also farther away from Jupiter's radiation belt, so you don't have to worry about shielding. There's a lot of trade-offs, but it's a mission. It will be more than $1 billion no matter any way you look at it, though. So I suppose that's the bottom limit. And there's the unspoken problem of the lack of plutonium-238 to power more outer planets missions at this point.
Although they're going to be restarting that, right? That was something that I heard.
It sounds like they're closer than they have been for a while, but again, it's one of those things that I'm not going to believe until I actually hear that they've produced a pellet of plutonium.
So the problem here is the decadal survey said they were going to turn it on. Then the congressional funding didn't fund actually turning on the process to produce the needed nuclear fuels, but it did fund a committee to investigate what is necessary to turn it on. So there's ongoing discussions on how do we do this. So it's a messy process.
And the plutonium restart thing it's one of those crazy Washington political footballs that has nothing whatever to do with the cost or the danger or the technology. We have the technology. The cost to restart is $20 million. That has not changed. It is, considering NASA's budget, it's rounding error. But there has been this long battle within Congress, not within NASA, but within Congress about who should pay for it, where some want it to be split 50-50 between NASA and DOE, and some advocates for DOE, the Department of Energy, want NASA to pay for all of it. And it's just $20 million. Yeah. I would like to have $20 million, but you know what? A lot of people in this country have $20 million. It's not that much money when you're talking about a federal program. And it's very frustrating that all of this fighting and wrangling and time has been spent on such a small portion of the problem of how we get spacecraft off the launch pad and out into the solar system.
Yeah, it's a really frustrating situation where we just need someone to own up and take responsibility for the nuclear materials. So somebody please raise your hand and say, I'm going to do it. So we also have a question from the same Greek fellow whose name I won't destroy a second time, who's asking if there's any updates on Apophis. And as far as I know, we're simply waiting for it to go through the keyhole, and all observations say we're good, we're safe.
Well, there are a couple things. One is that there's an opportunity to observe Apophis in 2013. I think that's a radar opportunity with Arecibo, and that may rule out any sort of collision threat at all. And just in the past week or so, the Russians have been talking about how they want to put a probe on Apophis during one of these opportunities to track it and really get a more precise reading on what its orbit is going to be like. Because if you wait until the keyhole, there is a little bit of a chance that you're going to be in trouble later on down the line.
And Emily, you're shaking your head on this one. What would you like to add?
I'm shaking my head because you don't want to test out a new idea of tagging an asteroid on the one asteroid that might actually prove hazardous to Earth. because you don't know if whatever influence you have on it, it could be tiny, but just don't mess with it until we know what we're doing in terms of rendezvousing with asteroids and anyway, mess with a different asteroid.
There's plenty of rocks
Russia.
Pick a different rock.
Pick a different rock, exactly.
So I think that's it for this week. I'd like to thank all of you for joining us. We have Alan Boyle from MSNBC, Emily Lakdawala from the Planetary Society, Nancy Atkinson for Universe Today. I'm Dr. Pamela Gay, and I'm co-host of Astronomy Cast with your normal host for this Hangout, Fraser Kane. And we look forward to having Fraser back next week, and we'd love to thank all of you for tuning in today. The next Hangout, I believe, is going to be Sunday night's virtual star party, weather willing, and that should begin at 8 o'clock Pacific time, which is 11 o'clock. Yes, 11 o'clock Eastern Standard Time, and we're going to work on getting all of the times for Europe and Southeast Asia posted again now that daylight savings time has settled its way across the globe. We'd like to thank all of you for joining us, and if you could please take a moment to please +1 the show. We'd really like to know you're out there listening. So thank you, everyone, and thanks, and enjoy Uri's night.